Dear ladies and gentlemen, I want to welcome you to one of the video tutorials with Polysun. Today I want to show you how you can start with Polysun. I want to give you a short introduction to the Polysun Design Assistant, and later on we want to change one existing system and do a comparison between different systems. To get started, I would like you to click on the symbol. It's a symbol for the Polysun Design Assistant, or as we call it, the wizard. When you start a project in Polysun, usually you start to give the project a name. And since our project is in Freiburg, Germany, I want to call it Freiburg, and it's the project X. So whatever your project's name is, just type it in here. And if you want your customer to have any additional information, just type any comment in here. With a comment, we need to be careful because this is something which we are printing out on the reports we are generating later. As soon as you decided for the project name and comments, the next step is to select the location for your system, and here you have two possibilities. The first possibilities is to choose the location from the map. As I said, we are in Germany and our city is Freiburg. You can do it like this, then you get the weather data immediately from the data points. The data points are coming from meteor norm, and we have the test reference years from the latest periods. If you don't find your location here in the database, you can simply change to location selection from map, open the map and type in the name of your location or the zip code in here. Then you can choose which Freiburg you have. This is Freiburg im Breisgau. So double click on that, and if you want, you can even zoom in here and you can define where exactly you are. So we confirm this with OK, and you can see here Freiburg is very close to the Black Forest, so you see already some hills which causes shading. This is important if you have a PV or solar thermal project. Please click on continue, and in the next step you are about to choose what kind of system you have. In Polysun currently we have around 1000 systems, and this is quite a lot, but it's not so many when you think of what is possible out in the field. So in our case, we want to run a simple solar thermal system. So we define solar thermal as energy provider, and we want to have a gas boiler. So heat pump is not allowed. We don't want to have a heat pump to get started, just solar thermal and gas burning boiler. And as consumers, we want to have a look at domestic hot water consumption and space heating consumption. So you find here different systems, and now you can choose for what kind of system you want to go. We want to go ahead with the next system. It's a system 9A. So you can double click here on this system, or either just go with a mouse on it and click on continue. Still, we have 200 systems, so there's a lot of systems you can have a look at. I don't want to spend too much time to go here into detail. So we use the system 9A, as I said, with a combined tank, and we are going ahead to give Polysun the most important information for the design. One of this is a load for domestic hot water, and here we have two possibilities. Either we type in the end energy demand, or we estimate the hot water demand depending on number of persons. There are different norms and standards, and usually the standards say that we have per person 50 degrees C and 50 liters per day. So whenever you type in here 6 persons, you will get calculated 300 liters as a daily hot water demand. There's also one field which is called absences. If you click here on these 3 dots, a new window will open, and in this window you can choose a different kind of absences. You can, for example, say Sunday or Saturday and Sunday is an absence, which means this kind of building would be something like a school or a business building where nobody is there during this time of the week. In our case, we are going for summer holidays, and we have 3 weeks summer holidays. So we click on this database entry. Whenever you want to have something else which you don't find in the catalog, you are free to create a new database entry. We're going to click on OK now and on Continue to define the building energy demand. In the building energy demand, we have also several options to define how much energy the building is consuming. You see here, heating energy demand is one possibility, fuel consumption a second one, heating load the third one, and monthly energy demand would be the fourth possibility. We are going to calculate with building dimensions, and this means more or less that we are using an advanced building model, which is implemented in Polysun. So please click on the 3 dots again to go to the database, and I want to enlarge this window a bit so that we can have a look what we find here. We have in the database different kind of entries like single family house, low energy building, single family house, normal building, and so on. And each building is described by physical parameters such as U value, specific energy demand, and so on. The most important values, since it is a physical module, is the U value of the building. And what you see here is the window to wall area ratio to south, north, east, and west. From these values, we can define about the amount of losses and also gains. So whenever you have a window south facing and the sun is shining, you have internal gains. You have also air change rate and air inflation rate, which causes other gains. On the other hand, we have internal gains, heat gains, and so on. Everything you can define here, including also heat capacity of a building and the G value of the window. For our calculation, I think it is okay when we go with a single family house, low energy building. Please click on OK and define in the next step the length of the building. We are going for 11 meters and the building is 6 meters wide. We have 2 floors, and this means we have a heated area of roughly 130 square meters. Our heating set point temperature we want to set to 21 degrees C. The last value you can enter is here the heating loop. So whenever you have a convector, you have low temperatures such as 40 degree inlet temperatures and maybe 35 return, or when you are going to choose a radiator, you have higher temperatures, and under higher temperatures your solar system will not run as good because efficiency of the collector is not as good under high temperatures as you can run it under low temperatures. So this is something which is very important for the simulation and also for the control strategy you might choose later on for your system. Nowadays 35 degree C inlet temperature and 28 is a kind of standard, so we are using this one. It's the database entry 22. Please click on Continue to define the solar system, and here you can enter all values for the collectors. It means, first of all, we need to choose what kind of test standard we are using. There's a European test standard, the Solar Key Mark test, but there's also a North American one, SRCC, and a Chinese one. We want to go for the European one and go into database and choose any random collector and for this one I want to go with flat plate premium quality collectors. If you are interested in what kind of physical parameters we have here, you can check the absorber area, cross area, and the efficiency of the collector. So all values which describe this component you find here in the database. Click on OK to get this collector in your system, and then you just need to define the orientation of your system. We define 0 as south facing. This is what you can see here from this collector field also. So 0 degree south facing, 180 degree would be a north facing collector. Probably it sounds stupid, but if you are in the southern hemisphere, you need to face the collector to the north. Tilt angle is something I think I don't need to explain. It's the angle between the horizontal and the tilt of the collector. So we want to go for 60 degrees C, 60 degree, not C, excuse me please. And Polysun is giving us now a kind of hint for the solar fraction. So whenever you want to go for medium solar fraction, Polysun recommends 7 collectors. If you rather want to have a low fraction, Polysun recommends 5. Whenever you have a different opinion here, you can also say no, 5 is not good because of a pressure drop, and with 7 I have the same issue. You can also go with 6 collectors, which equals a cross area of 12 square meters, and Polysun also recommends a certain tank volume, and here you can say okay, recommended is something like 600, or you could also change to medium, then the tank size would be much larger, but we change it back 900 liters, so you can choose a suitable tank size. 800, 900 is not in the database, so let's go for 1000 liter. Click on OK to continue, and continue here, and now we are more or less at the end. The last thing which is missing is the gas boiler, which is missing. Here we go again in the database. The tool recommends the size of 16 kilowatt. We don't have 16, so we could either go with 20 or with 15. So let's continue with 20 and start the simulation while clicking on accept. Now the simulation is running, and it's simulating 365 days of the year, so we are always doing a whole year of simulation with variable time steps. The time steps are between 1 second and 12 minutes, and at the end we just take out of this information the energy balances, so you don't need to be afraid. At the end you just have a value like solar fraction over the year and solar thermal gain over the year. So in our case, we have a solar fraction of 36.6 and solar thermal energy yield of roughly 5000 kilowatt hours. And this is always the first step to have a look if this simulation can be all right. Because here I see in July, hey, the solar yield is very little, but usually in July the sun is shining. What a problem. So you need to cross-check the results always, and yeah, you probably have it still in mind. In July we had 3 weeks of absences, so whenever we don't have any consumption, we cannot have a very high yield, and this is a problem what we have here. So please always check the results if they are plausible or not, and if there is something you cannot explain, you need to search for. Polysun is a physical simulation, so there are always explanations for that. In the next step, we want to try to optimize our system, and for that we can simply click on our existing variant, do a right click here, and copy the system variant, and we can give it a new name, and I call it larger tank And since we want to see if it's an optimization and the system really gets better or not, it is important to go back to the existing system, do right click again and set this as a reference system. So reference system means you have immediately comparison between the existing system where you have done the simulation and for the new one. For our simulation we will want to simply change the size of the storage tank. So we go in here, double click on the storage tank, and we see here storage tank there is a link to the database, and we want to choose for a larger one. We see here a 1500 liter buffer tank. We are going to choose it, and the other thing is we want to improve the numbers of collectors. Don't want to have 6 collectors anymore. We are going to have 8 one. Confirm it with OK. So it was the same thing. Just double click on the component, and by the way, you can do it with any component you see here, even with a piping system, with pumps and so on. And now we did our changes, and with clicking on result overview, we are asking for the results, and the simulation is running again. And after a few seconds we got our results, and now we see immediately from the solar fraction has improved. We had in the old system 36%, now we have 44%. If you want to see on basis of fuel savings what happens, you can simply go in this line and you see we have saved more than 1300 kilowatt hours for a normal year. From this value you can very easily recalculate if it is economically a good thing to have 2 more collectors and a slightly larger storage tank, or does it make no sense. At this point I want to show you also some other results we can get out of Polysun. Under results you find everything. So the simple thing is go to component results and have a look for results to each component very into detailed. So we have had a look at the collector. So this is what you can do now. Also here you find the collector field yield. This is the energy we get from the collector to the fluid in the collector loop, 6100 kilowatt hours. It was the same value we have seen in the result overview, but here we find also some other very important information, and I just want to show you a few. For example, days in stagnation, 17 days, and the most of them are in summer times, 4 and 5 during July and August. So from this information, days in stagnation, you can estimate, is your solar collector field too large or is it too small, and you can get a lot of information out of it. You can also go to any other component, as you see here, and get the values from there. So if I'm going to boiler, I can check what kind of energy losses I have or what kind of energy consumption. And the boiler, it's our backup system. This is quite clear. It consumes the energy during winter time because here we don't have such a high solar thermal yield. There's also another result which is important for you. This is a tabular evaluation, and here in the tabular evaluation you do have the values not on monthly basis, you have it on hourly basis. So you see you have each hour of the year starting with hour 0, the 1st of January, 0 o'clock, and then you have columns with the values from each component. To have an overview what components you have, you can click on this window, and here we can again go to the collector and we can check the collector field yield again, and you see you have the values on hourly basis. You need to be a little bit careful with these values, because here in the first hour of the year you have a negative collector field yield. 17 roughly 70 watt hours. This means just not that you are losing a lot of energy, it just means that the temperature of the surrounding is colder than the temperature of the collector, and yes, the collector is losing energy. As soon as you have at the same time a flow rate as here, it means you get this energy into the storage tank or out of the storage tank. So this means just temperature of the component is changing, and the minus or the plus is just it's just a question if the energy is going into the system or it going out of the system. If you are more interested in this result and you want to do experience with this, or you want to save it in some way, you can simply mark the lines which are interesting for you. Press Ctrl and C on the keyboard, go to Excel, open it, Ctrl V, and you have it again. And this is the easiest thing to get data out of Polysun. So there's no export function, it's simply Ctrl V and Ctrl C. I want to go out of Excel, and I want to show you another interesting output, which is called simulation analysis. Please click on it and run the simulation again, because here we save each simulation time step and we have all values in a graphical way shown. So it's very easy to get an overview in the system, temperatures, and so on. With this analysis, it's very easy to check what the system is really doing. Here, beginning of the year, 1st of January, for example, you see this loop is running. So our building is consuming energy, and if you go a little bit ahead, you see how the values are changing. The values in the storage tank, where we have 12 layers, and for example here on the 5th of January during noontime, we see our solar loop pump is running. We are gaining energy, roughly 6 kilowatt, and we are going back to the storage tank with a larger temperature as we have run into the collector. With this analysis, you can gain a very easy understanding of the dynamic of your system, and as soon as something is not going all right, you will immediately see where the problem is. So, for example, if the geometry of the storage tank is not all right, or if the control strategy doesn't work as you want to have it, then you will see it immediately in the system analysis. Since we want to do a comparison between different variants, I want to go back to our first variant, and I want to rename it. We will call it variant 1, and the second one we are going to remove, so we can also delete the system if we don't like it anymore. And we have seen we can simply get a variant out of the Design Assistant, but there's also another possibility. You can go into this file system here, click for example to standard templates, and we have a template with domestic hot water demand and also with heating system. So we can have a look in this one and check here if there are interesting systems for us. There are systems without solar thermal, there are systems with PV and combined, and we have done a system which which solar thermal has been a very important part. And in the second variant, I want to have a system which with a larger solar fraction. I want you to search for the variant 9D and simply click on it, and then Polysun asks you if you want to take this variant. We say yes, and we call it variant number 2. Confirm this with OK, and now we can do a comparison. Anyway, it's not so easy because in variant number 2 we might have some other data for the load. So here in this system everything has default values, but you need to check the important ones again. For the loads, the easiest thing is to click on variant number 1, do a double click on the domestic hot water tab and go immediately out with OK, because then Polysun asks you to transfer the values from the first variant to the second one. We say yes, we want to do this, and we are going to do it with the building in the same way. So at least we have from the load side the same values, and this is the basis to do a comparison. On the other hand, with that we want to have different collector size. I'm going to double click on the collector as we did before, and I start to choose the premium quality collector, and I want to change the number of collectors from 8 to 14. Confirm this with OK, and with a double click on the storage tank we need now also to change the volume of the storage tank so that it is suitable to the collector size. So we are going here into the database, and we can either choose for a suitable volume, or if you have an existing tank, simply copy it as line and say we want to have a 4000 liter tank. Click on the pan and now change the values which you find here, like volume 4000 liters, height, and so on. We can keep it as it is and confirm it with OK. Everything else we probably don't need to change, so maybe the boiler size is 12.5. Let's double click here and say we want to have the same gas boiler as we had before, 20 kilowatts. Confirm it with OK, and that's it. So the next step, we click on results, result overview again, also as we did it again, and wait until Polysun runs both simulations again. From this exercise you can see that it's very easy to compare complete different hydronic systems with Polysun and get results where you can start to do economical analysis out of it. So with our system with larger solar fraction, we see here we saved roughly 3300 kilowatt hours. To start the economical evaluation, we can close this window, go to results, and go here to the economical or profitable calculation. Start it, and here you have now a lot of parameters you can type in, such as time period, internal rate of return, and so on. So you define all your costs, you define your parameters you have, and gas prices, and so on, everything much into detail, and at the end you see the net present value, or if you have also like the payback period of your system. For this kind of analysis, we have done some other videos, and I want to refer to these videos at this point. So I close this here, and we want to start with creating a report. So under results, professional report, you have also the possibility to automatically create a report which you can give your customers, or if you want to get some subsidies, sometimes the institutions ask also for simulations. I want to show you the PDF report. I'll simply click on OK, and now it takes a few seconds until the report is created. On the report you see the overview about your system, so it's a hydronic again. You see how the project is called and the variant where we calculated, location on the system, and who did the simulation. Then you have an overview about the total fuel consumption of the system and also about the annual values of your collector. So solar fraction is something we give, and also the total yield. Please have a look at this report in detail, and yeah, whenever there are any questions, you can simply write us an email, or you can also have a look in our tutorial, which you find in Polysun itself. I'm going to close the simulation report, and we want to have a look at the next variant. In the next variant, we want to have a look at a system which combines solar thermal and heat pump. So when we are in our folder domestic hot water and space heating system, we can scroll a bit down, and here we find a system which is called 25A, space heating plus ground source loop and solar thermal. Again, we do double click on this, and this will be our variant 3. So we confirm that, and we go back in one of our previous systems just to get the load in it. So we just want to get it on the variant 3, and the same we are doing here with the building. Just go in and out, and our load will be the same load now as in the previous systems. We need to look at the heat pump. So this is one thing. We had a 20 kilowatt gas burner, so we also need to have a heat pump of this size, 20 kilowatt, to have something which is comparable. And we should have also a look at the collectors. On the collectors we had something between, I think, 8 and 14 collectors. So let's maybe go here again with 14 collectors and a tilt angle of 60 degrees. And this is also important, we need to choose the premium quality collector again and confirm this. Just to give you a short overview, what does this project actually, or this hydronic? The solar loop is running either on the storage tank, where the energy can be used directly for heating of the house or for domestic hot water purposes, or whenever the temperature in the storage tank is already high, so the storage tank is fully loaded, we will switch down the flow rate with this switching valve, and we go into the ground source loop, and we will feed the energy into the ground. This has different advantages and disadvantages. The advantages are that our collector will not go into stagnation. On the other side, we are not quite sure what happens here in the ground. If you have a single loop, the energy can simply disappear. If you have different, or not just one drilling, you have maybe 4 or 5, so you have a complete field, then you can store the energy over the year. So during summertime you will bring energy into the ground and you will get it back with the heat pump during winter time. So that is the next thing where we need to have a look at the ground source loop and the storage tank. For storage tank, I think we are fine with 1000 liter. Maybe we can increase a bit, but 1000 liter is okay. And the ground source loop, we double click here, and there are again different possibilities. First of all, you can define here in this field directly what you have, or if you are a bit unsure, you can click on wizard, and then it opens Swiss norm, the SEA, which estimated first of all the energy demand for space heating and the energy demand for domestic hot water. So it recommends a heat pump size, which is in this case a bit smaller, but anyway, let's go with a 20 kilowatt heat pump to have a good comparison. And we need to define the kind of material we have in the ground. So you can simply click on plus here to define what you have. So in this case we would have one layer medium sandstone, which is, let's say, 50 meters, and then we are going to get the normal sandstone out of it, and let's say this will be 120 meters. And depending on the parameters, the physical parameters of this material, Polysun gives us a certain length of our boreholes. So we have defined 170 meters, and now we can choose, do we want to have 2 boreholes, 3 boreholes, or even 4. I would like to go for 3 boreholes, 114 meters, and go on accept. So now we have some values for the ground source loop, we have our load values here, and we have defined our system, so we can start the calculation to run our system and to get the results. In our system we will see that not all solar thermal yield will go directly into the storage tank. Some of it will go to the ground source loop and improve the temperature here, and this will give the heat pump a better coefficient of performance. Okay, we got a small warning that there is a small difference in energy consumption. I immediately clicked on the total energy consumption to compare. There's a very small difference, and this has sometimes to do with the dynamic of the simulation. So maybe the heat pump is not as fast as a gas burner, and it delivers a little bit less energy to our system. But as soon as you have a look in this comparison here, you see the difference is very little. So Polysun is, when it comes to these warnings, very accurate, but it doesn't necessarily mean that you need to be disappointed about this. Probably the most important results you find here under component results, and when you have a look at ground source loop, because the ground source, we are taking energy away from there and we are bringing energy in. If you click here on the component results and ground source loop, you can see the energy balance, and you can very easily see during winter time we take a lot of energy out of the loop, and during summertime we bring a little bit energy back. If we have a look over the year, we have 4,400 kilowatt hours, which we take more out of the loop as we bring in. That means also that the temperature in the ground source loop will get lower and lower year by year, as long as we take more energy out of the loop as we bring in back, or as comes from the earth. So this is something you take into account, because usually when you build up a system something like this, then you need to make sure that the ground source loop runs at least 20 years or even longer. In Switzerland you need to run it 50 years. So what you can do is, if you want to analyze it for the future, double click on the ground source loop and type in the number of years you want to run it, for example 20 years, and the amount of energy you take out of the loop. So we had 4,500, we confirm it's okay, and we start the result with component results again. And now for 20 years we are doing a pre-simulation just for the ground source loop, and then at the end we calculate the whole system. So in the year 21 we are going to check how the COP of the heat pump is and how much energy now we take out of the ground source loop. And I'm quite sure that we will see in the ground source loop a lower temperature as we had now. And this lower temperature means always COP of the heat pump will goes down, and probably the collector yield will go up, because when I have colder temperatures in the ground source loop, then my efficiency of the solar thermal collector will get better. And now here we go for the results. So I'm going to check the ground source loop, and here from the temperature you see the temperature was going down, not much, but at least 1 degree. Please be aware, if your system is consuming more energy or if your system has less regeneration, then the temperature drop will be much larger. On the other side, as soon as you bring more energy into the ground source loop, as you take away from there, it could be possible that the temperature in the ground source loop will increase over the years. Okay, I want to go out of the system now, and in the next step we want to have a look at the last variant. The last variant will be a variant just with air source heat pump without solar thermal, and a bit later we want to add a PV system to it with the idea to run the air source heat pump with PV energy, and we want to see how much of this energy we can use for that. As we did before, we can go into the systems we find here, and I want to run variant 4 with this heat pump system we find there. It's variant 16A. So we are going to double click on it as we did it before, and I've been a bit fast, so to make it nice we will call it variant number 4. We need to go back to one of these other existing variants, as we did it already 2 times. So we are going to get the load data from the domestic hot water and from the house into our new variant. And in this system we just need to think about the storage tank. Since we don't have any solar thermal now, it's okay with a 600 liter tank. Probably 15 kilowatt heat pump is not enough, so we can go into database, can have a look if we have a larger one, but this will also be not the most important point, and we have seen that the other heat pump, the ground source heat pump, did also work with a smaller one. To have a very nice comparison, I want to set a variant number 3 as reference system, because then we can compare heat pump system with heat pump system. So that means we can compare electricity consumption with electricity consumption and not gas versus electricity. So after our very quick first system setup, I'm going to run my simulation now. In the results we see now that the energy consumption looks more or less similar. We see also that the heat pump, the air source heat pump, has a larger energy consumption, and this is simply due to the different coefficient of performance, and that our ground source heat pump has an additional solar thermal part, so this was also reducing the energy demand. Okay, what can we do now with this system? As I said before, we want to add the PV part. So this is something you can very easily do while clicking on PV here and then clicking on the working area. This symbol is a symbol for PV modules plus inverter. So whenever we have PV, we need something else. We need also to have a grid for overproduction or for energy demand, and we need to have these electrical consumers. When you click in here, I want to start with this, you can define that you have internal consumers which means you have computers, you have lighting and stuff like this. And if you want, you can include the electrical consumption by the thermal elements, and with that the heat pump is meant. So we leave it as it is, and to start the design of the PV part, we click with a double click on the PV field. Can either type in all values here as we did already with the solar thermal part, or you can click on the wizard symbol. This is what we did in the geothermal part, and define here our grid. We are going to have a 3-phase grid without any phase load imbalance and a cosinus phi of 1. We are going to define our system from the database. So here you can go into the database, choose a suitable module. For us it doesn't matter so much, so I'm just going to 30 modules. Tilt angle, let's say, is 30 degree. We are clicking on continue, choosing a suitable inverter. I have one from Fronius, and this is just a filter possibility, so you can change here to SMA or Kaiko or any other inverter manufacturer, and depending on the power ratio which is calculated here as a suitable one, or if you don't want to get it calculated by Polysun, you can simply type it in. Polysun delivers suitable inverters. We have roughly 4.5 kilowatt peak array, so with a SIMO 4.5 it looks very good. We can define here cable losses, either by using a loss factor or by selecting the cable sections, and define very accurate how each string and EC side and DC side is equipped with what kind of cabling. I want to choose a loss factor 2% and go ahead to has an overall validation. Here you see already everything looks alright, so the values are good enough. The inverter is suitable for our system. We are going ahead, and here we have again the possibility to choose a system for electrical consumption profiles. For our system we didn't take into account the residential consumption, so I want to go to 0 profiles, which means there is simply no electricity consumption for lighting and computers and all this stuff. While clicking accept and OK, our system is finished, and now I don't want to do this comparison. I want to reset the reference, and I simply want to go into this system and want to see the results here. So as soon as we start to combine solar thermal and electrical systems, we do something which is a bit different, because now you can also cover other needs of your users, not just deliver the user energy for warm water. Now you can also start to deliver energy for all other electrical applications. What we see here is we have a photovoltaic yield of roughly 5,500 kilowatt hour, and we see we have very little self-consumption. It's just 360 kilowatt hours. So that is the first thing which is important. Obviously the electricity consumption is running during a different time as we are consuming. So most of our energy goes directly into the grid. From these values now you can think of optimization tools. What would be possible to increase the self-consumption? Because nowadays we have in some areas of the world lower prices for electricity production with PV as from the utilities. So if you buy electricity from the utilities, it's usually more expensive. So let's go out of these results and let's check, for example, this controller. Okay, this controller allows us to run the whole day. So this is something what heat pumps doesn't do. So sometimes they are just set to run during nighttime, because a few years ago during nighttime the electricity was simply cheaper. Under an additional analysis, the graphical evaluation, you can now plot the electricity consumption. So I want to add one curve. I take the consumers as this curve, and I want to add another curve, the photovoltaic energy production on AC side. And we can plot it over the year. And here the first impression is we have electricity production more during summertime, but the electricity consumption is lower. We see either here the gap we have during summertime, and if we go a bit more into detail, you see the main problem is that the heat pump is running during different times of the day as we have the production. So what can we do? We can either change the controller, or we can simply use a battery to shift the load from day to night time, or we can easily say, let's run the heat pump just during daytime. There's also a disadvantage when you're doing this. It could be possible that the energy demand is not covered, because during night times your house is getting cold and the heat pump is required to run. We will see if this happens here. So it doesn't happen, so obviously the storage tank is large enough. And you see immediately that the self-consumption is increasing. You see also self-consumption is increasing during this time of the year, and this has simply to do that here we have the largest energy demand. In the next step, you could add a battery. It works in the same way. So just click the battery in the working area. You can go with a double click into the system database, and here we have a Hoppecker battery with 6 kilowatt. Let's say we are going to run with 2, so we have 12 kilowatt capacity. Run the results again, and I assume now the self-consumption will increase even more. Okay, here we go. Self-consumption now has more than doubled, so now we have 1800 kilowatt hours self-consumption, while we have a yield which is still constant, 5500 kilowatt hours, and our total energy consumption is something around 12,000 kilowatt hours, close to 13,000. Okay, I think for today it's enough as introduction for Polysun. Please give us a telephone call, or write us an email if you have any additional questions. And I hope you could learn something today and you get some skills to run your Polysun. Have a great day, and see you soon. Bye bye.